Good afternoon, everyone, and welcome. Thank you for joining us for today's webinar, Beyond Monitoring, the Digital Twin Mandate for Data Centers. I am Pragya Gupta, Product Marketing Manager, Neilsoft, your host for today's session. As data centers continue to grow in scale and complexity, the focus is shifting from simply monitoring systems to building connected, intelligent environments that improve visibility, optimize performance, and support faster decision making. That's where digital twin technology is creating real impact. By connecting BIM, BMS, energy systems, and operational data into a single intelligent platform. Today's session will focus on how digital twins can help data centers move from reactive monitoring to proactive and optimized operations. We are glad to have all of you with us. It's now my pleasure to introduce our speakers. First, we have Mr. Prasanna Dwejat, Delivery Head at Neilsoft. Prasanna carries an overall experience of 30 plus years in the field of MEP and infrastructure design for building projects. He is heading the MEP and infrastructure practice at Neilsoft and has worked on many mission critical projects like data centers, life saving labs, healthcare projects, and semiconductor plants for clients across the globe, mainly in the UK, North America, Europe, Japan, Australia, and India. He has worked with Amazon Web Services, Google, Micron, etc. in multiple geographies like India, US, UK, etc. He has worked on these projects from feasibility studies to pre-construction, construction, and post-construction phases. He has also worked on operational integration of design, including digital twins. Welcome, Prasanna.
Thank you. Good afternoon, everyone.
Joining him is Sandeep Agarwal, Executive Vice President, IT and Admin at Neilsoft. Sandeep, Head of IT at Neilsoft for the past 24 years, brings extensive experience in enterprise IT infrastructure and operations. Prior to Neilsoft, he worked with organizations including IBM, Garware Chemicals, and the heavy water projects. He has been closely involved in digital twin initiatives for data centers, focusing on real time virtual replicas of IT, power, cooling, and operation systems. By integrating data from sensors, DCIM tools, and IT systems, these digital twins help monitor, simulate, and optimize data centers' performance for more intelligent and efficient operation. Welcome, Sandeep.
Thank you, Pragya.
We also have Aniket Pichakate with us, who has been involved in implementing digital twins for various types of facilities such as data centers, hospitals, commercial buildings, and industrial facilities. He will speak about the digital twin journey from concept and design to intelligent operations and demonstrate a sample data center model as a digital twin. Welcome, Aniket.
Thank you, Pragya.
Thank you all for joining us today. Over to you, Sandeep.
Good afternoon, everyone, and welcome to this part of webinar. Today, we are discussing about, as Pragya mentioned, how digital twins can be useful, changing the way modern data centers are designed, operated, and maintained. So before that, everybody understands that what is data center. So data center is nothing but whatever we are doing in IT, ultimately the backbone of all this IT equipment is data center where it is interconnecting with the world. It is also processing our data. It is also processing payments. It is streaming audio videos. It is streaming movies and lot of them. But the data center, which is growing in a complex way, now has gone. The capacity has already doubled in the last 2 years, which is growing at 14% a year. The bigger driver is AI, and it is expected to make up half of the data center capacity by 2030, up to which was from the quarter 2025. This is fueling a massive 3 trillion investment super cycle through the end of the decade. And there are 11,000 data centers worldwide across 174 countries, with US leading around 4,000 data centers. Coming to India, India is one of the fastest growing markets and expanding from 2 gigawatt today to 4 to 5 gigawatt by 2030. to companies, and most of the companies are using because India is a market and the data center requirement is growing in India. So most of the Indian capacity is concentrated in Mumbai, Hyderabad, Bangalore, Chennai, and Pune. And government has also given the infrastructure status and the data localization rules as per DPDP Act. So government has mandated everyone to keep the data in India, and that is also adding the requirement of data centers in India.
And the tax holiday is also Sunday.
Yeah, and the tax holidays also. So government is promoting that, as Prasanna mentioned, through our tax holidays, so that people are encouraged to build more and more data centers. Today we are discussing how digital twins are changing the way modern data centers are designed, operated, and maintained. So most people think a data center is just a server or a rack. As we have seen from the beginning, like every company will have small server, small rack, or something at their place, which is nothing but a data center for that particular company. In reality, it is a living ecosystem where IT, power, cooling, operations, they are all interconnected. And when something fails, for example, UPS or cooling unit or airflow balance, or the impact can be cascaded in seconds, and you will feel the difference. Like sometime back, UK, all of a sudden, nobody could book a flight. So similar thing can happen if one of the elements goes down or malfunction. So today we will show you how continuously synchronized virtual model helps operators predict, simulate, and optimize before incident occurs. So we are covering data center reality. We'll start with the operational reality of data centers. Then discuss why traditional monitoring is no longer enough, and finally show how digital twin supports the entire life cycle from design through operations and predictive maintenance. So Prasanna, we are all ready. So let us see how it can happen. Okay.
Yeah, it is always better to start with discussing some of the failures that we heard in the recent past, which could be, I think, a good driver for anything that we are going to cover today, Sandeep.
Yeah. So if UPS B trips right down in your facility, could your team identify the blast, the radius is in under 10 seconds, that what will happen? What could go wrong? You have to go through many drawings, many documents, and find out that, okay, UPS B was connected to this particular data center or this particular rack, and this will happen. So because the dependencies are spread across BMS screens, electrical drawings, and spreadsheets, this is where digital twin connects those dependency, instantly gives you what will go wrong, what can go wrong, and in case they are configured properly, they will give you indication that do this action so that your impact will be minimal. Yeah, Prasanna. So this wakes up the call of the industry, the cooling system. Now you can talk a little bit about cooling system. Coming to the next incident, like we had done, we had discussed about the UPS.
Yeah.
Some time back, Google and Oracle, the London one, when cooling could not be kept with the climate, what has happened? And this has gone wrong just because they did not design it properly. Prasanna has experience, and Prasanna, you can talk a little bit about it.
Yeah, so it is very important to kind of cover your design with all the possibilities because data centers are all about uptime, right? So if you want to record a highest uptime, your systems should be designed in such a way that they cover all the possible things that can go wrong. Like in this particular case, the ambient temperature was recorded as the highest, and one of a 100 years time, and there was a big issue with ambient temperature going beyond 40 degrees centigrade. So for such eventualities, you should always have the buffer in your systems and the overall load that you cater for, so that it can cover such situations in the future.
Yeah, so Prasanna, you are saying that traditional redundancy which we used to keep, they just not enough to take care of the future growth, because exactly n plus one is not intelligence. You have to have the traditional system. Beyond traditional system, you have to have a better design and the future requirement right at the design stage.
Correct, and that boils down to design of that n configuration, right? If the n configuration is designed with a capacity enough to cover for all the eventualities, the redundancies, whether it is n plus one, n plus n, depending upon what tier you are designing the data center for, really doesn't matter.
So what is happening here is, in addition to the normal workload, AI has given a bigger workload in data center. So AI workloads are changing everything, right? So rack densities, and person has worked on all those requirements.
So typically, what has happened is because of the kind of AI computations that are being done on the data, the requirement of drag density is going very high. I'm talking about the last point first because everything typically boils down from there. So we were traditionally talking about a rack having a 30 kW load or 40 kW load, but the scenario has changed with the increased AI computations, taking those rack capacities to as high as 100, and we have been working on some exceptionally very high, ultra high density racks with about 160 to 180 kWs per rack as well.
Yes.
So what it does is it increases the load not only on the cooling system, electrical system, but also on the flow loads. And typically, it's all about, as I said, keeping the uptime highest. So 24/7 operations. And when we say that, it has to have a very good amount of modularity and kind of scalability without kind of disturbing the existing infrastructure. And if you look at the overall load that it takes, electricity cost is the highest when we cater for any data center. So 40% of the cost goes on to the electricity, and most of it, like about 70%, goes on to the cooling itself as a service. And when you have any downtime, the repercussions go into dollars. So this kind of necessitates the continuous monitoring of such mission critical projects. So typically, when we talk about a data center, we need to continuously monitor uh, four important things. One is the power. So power, there are multiple sources of power in a data center. So it comes from utility services. It comes from UPSs, batteries associated with it, and generators. And typically it goes to the PDUs and WAN circuits. So monitoring the power at the UPS, at the rack level is very important. And monitoring and simulation, because the current VMS systems are able to monitor everything, but there has to be something which can come in the form of a digital twin, which can kind of not only just take those things recorded by the BMS system, but kind of simulate that and process that at the back end to take the informed decisions in terms of the operations of the data center. Similarly, second is cooling systems, which is the second most important thing, where we can always talk about what type of units, and these needs to be continuously monitored, whether it is crack units or CRAH units, chillers, pumps, and so on. And third is the IT load. So typically, the health of a server rack needs to be continuously monitored in terms of its temperature and the performance, so that anything that is potentially going to go wrong is known to us beforehand, and we can take required actions. And fourth layer is the environment. So we have to continuously monitor the temperature, humidity, airflows, leaks, or security and smoke generation.
So eventually, Prasanna, you are talking about continuous operation risk, right?
Yes.
So monitoring alone isn't enough. So dashboards will tell you only what has happened, but what will happen or what can go wrong cannot be predicted right now with the current BMS system.
That is where the predictive maintenance comes into picture, right? So what we have to do is what we have to continuously monitor second by second, keep a kind of a track of the historical data so that the predictive intelligence can be taken from the digital twins. So for example, when you talk about electrical power, so what voltages, what currents, what frequencies, what is the power factor that is being continuously monitored, and then what kind of harmonics that are getting developed into the system, what are the UPSs batteries are working along, and then we have to do the general routine maintenance of all these equipments, including the generators, the ATSs associated with it. Similarly, for the cooling and mechanical, we have to continuously monitor the supply, return air temperatures, chill water temperatures, and the flows. The delta T's across the circuits from supply to return, and then condenser pressures, chiller efficiencies, and so on. So all these kind of track and taking the information from the VMS systems and simulating it and kind of working on it to give you a predictive analysis of the data and giving you signals upfront is important. Similarly, for environmental things, it is about keeping a track of all the temperature data, humidity data at the cold and hot oil, so that we monitor those temperatures to kind of get an advance notice about any future potential failure.
So, Prasanna, we are talking about two separate things here. Like we continuously monitor the parameters of electrical, cooling, environmental, safety, security, and sustainability, whereas IT is monitoring the server related loads. And this is where what is happening on server related load because of the rising GPU utilization, because of the increasing rack temperatures, because of the fan speeds inside the server, outside the server, and elevated UPS views. So all these things put together, it is becoming very complex situation where we are trying to monitor second by second and find out what exactly will go wrong.
Correct, and it is mainly because of the very high-end GPUs that these data centers are of late using, right? Because of the AI and deep learning things. So they are required to do a lot of parallel processes and activities. And with the trend of liquid cooling and immersion cooling being advancing in a big way, these things are becoming more complex.
Yes.
When it comes to mechanical MEP systems.
Because the ultimate goal is to achieve more that rack density. In the same rack, we are able to put more number of servers, more number of GPUs, and achieve the same. And this is where it will increase the power requirement of particular rack.
Correct. Now, when we talk about what typically goes wrong, like 10 years ago, we used to just typically say that it's tier three, so it has to be N plus one. Good PUE concept was also different. Now people are talking as close as possible to one, which is really ideal scenario. It's not really just PUE, but they're talking about improved CUVs, carbon usage effectiveness, which should be they're looking at how can it be close to zero, how can we do a carbon neutral developments, and then like this is all pushing us towards liquid cooling, use of renewable energy, integration of renewable energy, whether it is on site or off site, using things like solar and wind for doing the renewable energy, making the development self-sustainable. And similarly, for the water utilization, also they're trying to use as much recycled water. How can we minimize the water usage, avoiding any water cooled systems in the design of the data centers? So that has been the new trend when it comes to making everything possible within the constraint.
So customers now expect facilities to adapt continuously. That adaptability starts during design and not after commissioning. So now people are thinking beyond the construction of data center, but they are starting right at the design stage itself. So what kind of decisions we are really taking for so as to avoid the long-term impact on such system?
Yeah, so typically the design briefs, if we really look and see, it has changed in a very big way. Like people are talking about the very high demand of power, like very high density or ultra high density racks, and that too with coming up with liquid cooling or submerged cooling. Then they are talking about use of hybrid cooling systems and then multiple sources of electrical energy. So typically, it all talks about whether you're taking it on grid or off grid solar system. BESS is the biggest growing trend for such developments, but battery energy storages. Fuel cells is the time to come and now getting up very quickly. So all these different things are important. Then when we design any MEP system for HVAC system for the data center, typically we're talking about an upper bound of 27 degrees unlock, like to have some extra free cooling available. And then with PUE, WE, CU targets, we're talking about how do we make our sustainability approach clear right in the design stage by talking about how do we make it more closer to one for a PUE or closer to zero for CUV and closer to zero for WEB. So this all and apart from that, we also are talking about operations through instrumentation, right? BMS system is the basic. We are also talking about EPMS and DCIM, where power monitoring systems and data center infrastructure management system.
So you mean to say the digital twin is not an add-on, but it is best digital twin is the one which is added at the time of design itself.
Yes.
So Prasanna, what will yeah go with this? Yeah.
And typically, like when we do kind of electrical mechanical system design choices that move PUE and uptime very big way. So we are talking about redundancies, right? So redundancies should be at the tenant's level. So if we want to make any tenant failure proof, we have to add redundancies right at the provisions being made for each tenant, right? Then similar about we talked about medium voltage UPSs for data halls which are greater than 5 megawatt. Uh, when we select the transformers, we need to select K-rated transformer with active harmonics and harmonic filters and everything for power quality related improvements. And these are the different things that we can do in electrical. Similarly, in power, in case of cooling and mechanical, we have been adopting in a big way a hybrid topology in a single hall, a combination of air cooled chillers plus rear door heat exchangers or liquid cooled systems and so on. Similarly, we talked about the design conditions. So typically, these are the different steps that we need to really think about right from the design stage of the project to increase the PUVs, improve the PUVs and uptime of the data center.
So that's a huge mindset shift, right, Prasanna?
Yeah.
And this is where a digital twin is becoming the necessity or compulsory to have, because then it will remove all the PDFs, all disconnected documents, all living operational models, and the digital twin is continuously synchronized with virtual replicas of physical data structure. So what exactly we are doing is how it is different from BIM and DCIM, Prasanna?
Yeah, it's actually say I would say it is a combination of both of them. Typically, what it does is BIM model will typically give you the geometry and the information associated with elements that are there in the model. But it has to be added with live telemetry, simulation, and then operational context when it comes to the predictive intelligence in the system.
So it behaves like a dashboard, but not only dashboard, but it is like a more living system where what exactly is happening right now, second by second, at this point of time.
Yeah.
So one of the biggest misconception is that digital twins are only for operational tools. In reality, it doesn't seem, as per your, you have already experienced in your concept and design stage, and you have designed so many data centers, which takes us to the conclusion that digital twins are not only operational tools, but it will continue through commissioning, operations, maintenance, and future expansions, like a facilities management. So one twin across the whole life cycle is the conclusion right now. Prasanna, where is the huge cost of saving happens? So where exactly we can save if we adopt a digital twin and if we don't adopt digital twin?
Yeah, actually, as we said, when we talk about a data center, the majority of the operations cost is in the MEP systems. If you're able to design your MEP systems in such a way that they're most cost effective, and when it comes to actual operations and maintenance, how can we make them more efficient in terms of taking any kind of shocks or any kind of peak loads, and how your things are properly designed. So if we have a model, a virtual model of the facility developed in a very good way right from the beginning, then you can use that to simulate things like airflows, power distribution, and things like that in a digital twin very successfully. And that is the reason it is very important for one to kind of adopt to the thought of digital twin right from the design, construction, and then operations and maintenance, of course. When it comes to operations in day-to-day activity, it is very important. It is also important for keeping up with the facility management and as well as the asset management. When I say asset management is very useful in case of any augmentation, any movements that we're going to do in the future to cater for the future requirements of the facility.
So you mean to say we can do mistakes while we do digital model, but we can't afford those mistakes while we do physical before the concrete is poured. So much cheaper to have fixed at the simulation level itself rather than at the steel and concrete level. So what do you say about the construction and commissioning related advantages during the modeling or digital twin, with digital twin and without digital twin?
Correct. So handing over such a facility has been a biggest pain, right, for a construction industry, because construction as a civil construction or a physical construction has been mechanized to a great extent. It can go faster and can be completed with new records that are being kind of done every day. But the most painful area is handing over the infrastructure that has been developed within a data center kind of a project. And I think if you have built a right model using BIM right from the beginning, from concept stage to construction and construction to operation stage, then it is very easy to kind of have it interacted with a digital twin. So digital twin not just only takes the information from the models, but it adds a lot of intelligence on the top of it. Plus, it also has the record of every asset inside the facility. So this is something which has brought a big new dimension to the operations and maintenance of Triangle.
Correct. So that means with digital twin, the assets are digitally tagged, commissioning and scenarios are simulated, deviations are identified, and operators train before the data center goes live. So there is where this is where the operation team see the biggest daily value, and from the operation point of view, I have seen the difference when we have implemented digital twin at our facility, at our data center as well. The twin becomes a operator cockpit, and you can very easily see what is going wrong where before it actually gives a bigger impact. Imagine asking, if I shut this chiller for a maintenance, what will happen? If I if I do this thing, what will happen? So getting the answer before touching the equipment is very easy as far as digital twin is concerned. Over to you, Prasad. Next slide.
Yeah, so whenever it comes to kind of maintenance, always there are two things. We have been traditionally doing a reactive maintenance, right? Maintaining something or doing something after something fails. But it's not really a choice when it comes to projects, mission critical projects like data centers, right? Because there you have to be on the top of everything, and we have to know things that are going to go wrong well before, so that we can take the required actions and keep up with the highest uptime, which is a basic requirement of a data center. So we have been typically doing all these traditional reactive things, but they're not going to be useful any longer, right? So in that case, what we have to do is we have to really kind of rely on a digital twin. And again, when we say digital twin which is well thought about right from the design stage, and then has all the required simulation capabilities when it comes to different systems that are installed and operational within a mission critical project like a data center. So when it comes to that, it not only just takes data, but kind of works on that data and takes the operational intelligence, predictive maintenance related decisions are using those. So, for example, Sandeep can talk about some of the examples.
Yeah, so we have seen digital twin detects abnormal patterns in vibration, harmonics, thermal drift, battery curves, all those things when we could not have seen by a traditional maintenance approach. We have seen the difference in the predictive maintenance, and we could see that the output of digital twin. So what operational pain points disappear when digital twins? There are three major ones. One is, oh, sorry, two major ones, the standard capacity and slow root cause analysis. So when we talk about root cause analysis, first of all, the failure may not happen, but if failure happens, we can very easily find out what is the root cause without digging through a bigger logs and lot of data and then find out what has gone wrong. And it will give you exact reason of the root cause of failure.
And is it because typically a digital twin enables the systems like BMS, UPMS, and DCIM integrate and talk to each other to come to a very easy conclusion?
Yeah, it's a single contextualized data fabric where you get everything at one place, and it's actually it these failures will not happen, but before failure happens also it gives you lot of things like twin based in trains, and then you can take a planned maintenance for one particular section of the equipment, and you can very easily avoid the bigger failures and its impact.
Yeah, and I would like to talk about the recurring hotspot thing also, Sandeep.
Yeah.
So if we look at some of the digital twinning and energy management tools, they typically do a real-time CFD, like a thermal map, which can provide you a kind of warning in terms of any hotspots that are getting developed, which is the last thing that a data center operator would like to have in his facility.
So from an engineering perspective, as Prasanna has mentioned about, it will directly give us even airflow inefficiencies, hidden hotspots, and these things will be visible when Aniket will take us through a demo where it will show you hotspot thing and how it will be, how it is seen before it happens. So, Prasanna, what exactly is the biggest failure, or you can say important parameter where IT will not be able to do anything.
Yeah,
Yeah.
actually, uh, typically the cooling set points, optimization of the cooling set points, right? So if the supplier temperature is raised safely using live CFD and rack level inlet data. So if you have a inlet data for every rack and every this thing and a CFD analysis simultaneously running, you can easily make a decision based on that for the airflows. Similarly, for the fan speeds or pump speeds, so this can also be taken from a VFD speed at the actual load curve and not as the design assumption because you're now tracking the actual live equipment that is running in the facility and not the design data that some manufacturer sitting in a facility has given it to you.
So coming to the graph here, the bar graph here, you can see before digital twin, the PUE was lower and the for a given load, whereas for the same cooling, you are getting better IT load. For the same cooling, for the lesser cooling, for lesser power loss, for lesser lighting ox, you are getting better IT load.
Yeah.
So, yeah, Prasanna.
And it has also to do with the lower carbon footprint also.
Correct. So let us
by the use of not only the lower power but also by using renewables.
Yes.
For most of the
Yes.
power.
Power. Yeah. So this may be a most powerful capability of digital twin, where the graph model understands relationship between every asset, like we have seen UPS, like we have seen the hotspot, like we have seen the thermal map. Here, as Prasanna has designed many of such data center before they were built, he has simulated and he could find out, and by visualizing the inefficiency before incidents. Yeah, Prasanna, you can talk a little bit about it.
Correct, correct. So typically, as we say, when we design certain things, we do it on the basis of some assumptions, right? But when you are using something like a digital twin, you are actually finding out the inefficiencies in the operational systems before a failure or incident happens. And that's very important for mission critical projects like data center because it's not for you to do something after the incident happens. It's before that happens, and even much before in advance you get the notice or the flags.
So during design stage itself, we will find out that here my airflow or my hot air pockets can increase the impact on my efficiencies. And this is where he has used this technology for making it better. So as we have seen in the first slide, that UPS B trips, what will happen? So this graph database which is seen here shows you exactly what is happening. So in this case, UPS A, B, C, out of that UPS B tripped, and it has given because it was feeding a supply to switchboard SB2, and it was giving supply to PDU3 and PDU4 and rack R24 and rack R29. So this is simulated before the design as well as during the operations. So what has happened? Now we come to know that there is no redundancy here. So what we should be doing? We should be adding the redundant path for PDU3 and PDU4, rack R24 and rack R29, which are at risk. So it was through N+1 design and through the redundant power supply, we have simulated that, and the incident were reduced after the system was commissioned. Yeah, Prasanna. And okay, from operation point of view, we have seen the resilience, which is very much required for a real business outcome, because any business will, before spending anything on such technology, they should know that what is outcome of that. The goal isn't just monitoring the failures, it's preventing them, and this prevention can be proved to our finance or the CIOs or CEOs of the company, where we can prove the resilience of adding such parameters and such equipment by simulating it and by actually showing it to them the difference. It will definitely reduce the incidents. It will give you mean time to response, reduce mean time to response, and then stronger SLAs and audit trail will definitely prove that this is where we can improve before it is happening. So where the number, how fast they should show up. Okay. So we have seen actual experience I'm talking about. Typical return come from the lowering of cooling energy, avoiding downtime, recovered capacity, and then faster commissioning, because this design stage itself we have seen that everything is taken care, so commissioning is done very fast because we know everything about why we do commissioning and ultimately the operational productivity. In many cases, preventing one major outcome justifies the whole investment, and these are the numbers which has proven actually it has happened. The capex deferral again is another additional advantage, because we know that this particular thing is going to take this much time, and after this much time we have to invest in this, and we can plan our projects as per that. Of course, the sustainability credit is additional advantage, which is automatic, and which is nowadays regulators and carbon footprint and other things are already being asked by government and other agencies. So Prasanna, now we should be, how we have done as of now. We have implemented digital twin, but digital twin requires lot of sensors. So those sensors are to be monitored, and this can't be done by a regular BMS system. Every digital twin will require the, you can say, customized way of making it happen.
Yeah,
So
why we say that the system should be like architectural neutral. It should be able to work with any kind of topos, and that is the beauty of some of the things that we use on our digital twins and the environmental systems that we typically have.
So this is our product called Enviro Optimus, and it is unified digital twin platform for all data centers, which is single platform. Even if you have multiple systems inside the data center, like for temperature monitoring, for data center, for racks, for fire alarm system, for cooling system, all those sensors can be easily customizable and adapted and implemented to this product. It simulates, it predicts, and it also gives you the whole life cycle, because this is closely integrated with Enviro Optimus. The biggest advantage is it's open and it's vendor neutral. So even if you have a different sensors in place and we have to add more sensors in that system, we can add based on our requirement. Yeah, next slide, please. So what Enviro Optimus delivers, and we are going to see a live demo. Aniket is taking us through the live demo of Enviro Optimus, where we'll be seeing the data fabric, the real-time heat maps, and it gives us anomaly detection. Yeah, Prasad. So this is what we were talking about hotspots. Prasanna, you can.
No, it is all about the cooling system performance, IT loads, power infrastructure performance, lighting, and any other auxiliary system.
So this is nothing but a graph where we have simulated and we have also implemented these things like grid power, how much energy we have drawn from grid, how much energy we have drawn from DG, and how it is getting bifurcated across all the components of data center like chillers, CRAC unit, cooling towers, server racks. So we can analyze every aspect of the energy requirement and energy consumption.
Yeah, I think it is better we take them through Niket's demonstration.
It is based. Yeah, Niket, you can be ready for a demo. We will just explain about how it works.
Stop sharing.
Yeah.
I'll stop sharing, Niket.
Sure, I walk you through the digital twin demo. So before starting with the live demo, so the building you can see in my basically profile. So this is our NISOP campus. So our journey with digital twins started with our own building. So the use case, so the NISOP is our first client to have this digital twin. So our focus is energy monitoring as well as energy consumption. So we started our journey with our own building. Now I would like to share my screen and walk you through the digital twin for one of our data centers. Yes, I'm sharing my screen. Just let me know if you can see the beam model. Yes, and the bit is visible.
Yeah.
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 So yeah.
What
So
exactly?
talking So talking about digital twin. So this is a digital twin platform where we have imported our BIM model. So this is a data center, a floor model. Once we have imported that BIM model, along with that BIM model, we have the information coming from metadata. The information usually add during design phase, construction phase, and again in operational phase. So let's say if I click on any particular data center rack, now I can see the information coming out of my Revit model, my BIM model. You can see the design properties as well as its OEM information, from which OEM the model is coming from, model number. So this information we are receiving from the BIM model. Along with that, we have added retrofit IoT sensors nearby particular data center rack, so I can have the understanding how my data center operating, at what temperature the particular rack is operating. Because when we're talking about data centers, temperature is a crucial part. So we have to have maintained temperature below 25 degrees Celsius in particular server room. So this is all the racks of data centers we are monitoring, and sophistically we can see, if I click over here, I can see the number of racks having a particular alerts. That's mean the particular racks are not working on their optimal uh, condition. So I can quickly go to my particular rack. So this red color highlighted that particular rack is not uh, behaving as per their the IoT values. You can see the energy consumption has increased. So there is a limit we have added to each rack. If it cross that particular threshold, we will get those alert and notification. So that facility team technician to have to do a certain decision on particular rack. So along with that, we have also embedded the PDF. This is a technical manual technician can follow to solve that troubleshoot. So you can go to that technical documentation. Parallelly, he can also see its consumption pattern. So this is the IoT monitoring you can see in the display. So the technician or facility manager can go and understand the behavior of particular equipment. So digital twin is really allow you to have a common data environment where all your information is centralized into the single platform. And this is really helpful for facility manager to take a certain decision, because he has all the necessary information available at single place at single time. So taking a decision is very easy for technician or facility manager because he has all the information. So usually happen this information is available in silo format. So he has to go into the BMS room, but for technical maintenance information, he has to go to understand maybe asset management software when that particular rack has been serviced, Here you can also see its maintenance record, the rack number, ID, when it install, who install, as well as its operational status, where it is working, operational, or routine maintenance requires. So having all information at same place is really helpful for technician to do a quick decision on top of that. So parallel, let's say we have a number of racks. So if you look into any data centers, you may find out there are maybe a thousands number of racks. And to manage and operate all those racks is very crucial. So how digital twin can help in that case? You can basically create a digital twin for entire your data center. Now you have the understanding of how your equipments are behaving, how the transformers, AHUs, even your rack servers are behaving. So here in the left side, if I would like to see how many my racks require a routine maintenance, so I can quickly select that filter and I can able to find out, yes, these are the couple of data center racks that need a routine maintenance. So this information can be come from your asset management software as well as your inventory system or any third party enterprise based software which is required for your equipment management as well as asset management software. So here what we have done, we have covered your IoT monitoring as well as asset monitoring. So parallelly, if I so basically we also have created some dashboard. If I go to the dashboard which is responsible to have this asset monitoring. So this is a centralized dashboard where you can see all the data center racks. You can see its installation date and operating status, whether it is working, require maintenance. So you can quickly troubleshoot that particular rack, and you can see all those information available over here. Along with that, technical sheets, installation date, warranty date, who installed this, all those informations are available into a standardized dashboard format. Parallelly, one dash we also have created a dashboard for energy consumption. So here you can see how your transformers, how you are consuming the energy on particular floor. So floor wise dashboard we can also configure within our digital twin environment. I can quickly troubleshoot in any s- transformers and have the real time understanding how my systems are consuming the energy. So additionally, we also have one more dashboard that talk about thermal monitoring. So as I mentioned, thermal monitoring is a crucial part in any data center. So to make sure we are under a particular threshold limit. So let's say if any server rack temperature goes above on 30 degrees Celsius or 28 degrees Celsius, that is very critical for its life cycle. So to make so we have to make sure if any rack goes beyond its temperature, our facility team or technician team should go get those alerts and notifications. So that pipeline we also establish in our digital twin environment. So this is all about how we are monitoring our assets, equipments based on the data coming from the BMS system, IoT sensors. So parallelly, I can also talk about the heat map, which Sandeep and Prasanna have talked about. So in digital twin, you can have this real-time heat map visualization. So based on temperature, that can be a based on temperature. But you can also add additional parameter for which parameter you have to see the heat map. But usually we will keep that heat map for the temperature side. So we install temperature and humidity sensors to each room for the data center. And you can see some heat map pattern. Some of the rooms have the higher temperature, while some of the room has the temperature below 20 degrees Celsius. So this is the way the technician can quickly understand how their floors of data center is operating.
Yeah, similar way, Aniket, we can also create configuration or presentations for airflows and any other parameters like voltage or current being drawn and all
Yeah,
that, right?
like energy.
Correct.
So this is for room level. We also done for rack level as well. If I go to the rack level monitoring, let me change the particular view. Now we are coming into the rack level. So which rack is consuming what amount of energy at what level of temperature it is operating, that we also have done. I can see how it is operating in the past. So when I'm talking about digital twin, definitely we have the IoT sensors reading so that we can go into my past. So I can go yesterday, the day before, the last week, last month, and I can troubleshoot how my particular data center, particular rack is behaving in that particular week. So
So
here I am just
based on this, we can predict that there's something wrong there. Based on that, we can also analyze if something has gone wrong.
yes, we have all those data available with us. So once we have the data, we can make that data workable. We can do the AI predictions. We can find out the anomalies based on our uh, AI monitoring. So that predictions we also have done in our Envir Optimus product.
So all these thing was done using Environment Optimus as additional tool and additional product along with digital twin because there are a lot of other advantages like I mentioned in my previous slide what exactly Environment Optimus does in bringing digital twin at data center and giving us a better picture of how my equipment are working and how they are behaving over a period of time. So I have a small video which is not having any sound, but I will just take you through that so that this will help you to understand what exactly Enviro Optimus does. Give me a moment, I'm just sharing that.
Meanwhile, please feel free to post your questions in the chat. After the video, we will be open the floor for the question and answer session.
We have one more question from Shiva.
Yeah. We
So
have.
yeah,
So maybe after the video, we can
yeah.
answer that. Yeah.
Person I can unshare, I will share that.
Share, share.
Is it visible?
Yes. So as we mentioned about the building side, so there are different protocols available in any building or any factory, like the BACnet, the Modbus, the MQTT. All those protocols allow us to integrate our operational data. So you can see the 3D modeling of any facility as well as the monitoring dashboard. So BIM is our foundation of the foundation for the asset data. So all those information of any building which is coming from BIM. Then physical facility where we have the information coming from the BMS, SCADA. So this is the first layer of information where we have the metadata along with that BMS as well as SCADA data. So on top of that layer, there is a environment optimus layer where the data coming from BMS, retrofit, IoT sensors are came in that particular layer. So environment optimus particularly hold all those information coming from your BIM model as well as the information coming from your BMS, SCADA, all those information categorize, monitor, demonstrate in that environment optimus softwares. Once we have all those IoT information, operational informations, so that information is really helpful to do a predictive analytics, asset maintenance, and to find out anomalies. So this is our end-to-end cycle, how we start from design up to the operation, up to the delivery stage. Sometimes you have a question, yes, we do not have the BIM model, so what is the alternative solutions? So definitely that would be okay if you don't have the BIM model. So still we have a solution, we can use scan to BIM to create. So that can be possible. Let's say if your building is lightly more than 50 to 40 years old age, definitely there would be a no BIM model. But what we can do, we can simply scan the entire facility, converted scan into the BIM model. Then we'll start our IoT sensors retrofit installation as well as BMS integrations. So that would be not a challenge to create a digital twin. So sometimes we have those questions for the existing facilities. So here we have some of the examples of one of our data centers where we implement digital twin. So we have all those information from temperature and humidity sensors, how it operating thermally, its cooling inefficiency, unplanned downtime. So all we can demonstrate into the digital twin platform. And again, we dashboard we also demonstrated. So this dashboard can be also validate and also be exported into the PDF format. So I can export that dashboard to my executive team so they can have and look into it. And these dashboards are highly customizable. So this is our end-to-end platform for delivering a digital twin solution by using Envor Optimus product. Uh,
Thank, thank you, Aniket, Prasanna, and Sandeep for the wonderful session. Now we have few queries. Uh,
Yeah, first is I think Shubham Gaud has asked. Shubham.
Yeah, I can respond.
Yeah.
To that. So for Shivam, for a good for a beam you, it is more important for you to build the model which will be useful for digital twinning, first of all. So what does that essentially mean is you should have all the different MEP systems properly modeled in Revit so that the as-built model that you'll build at the end of the project can be taken as a digital replica for kind of interfacing with the digital twin and the platforms like EnviroOptimus to do the rest of the work that we discussed about the monitoring and management of the energy related things.
He has also asked about the skills required for going to this.
Basically, skill that you need for doing that is basically to be able to understand what information is required to be there in the model in terms of the performance of equipments. Geometry, of course, is important when you do the construction, clash coordination, and everything. But what goes to a digital twin is more of information in terms of what are the capacities or what are the requirements, what are the maintenance requirements of the equipments that are there in the building. So if you heard about something called as FOBI, so that kind of a thing where we actually do actual asset management and facility management using those Revit models.
And again, for integration side, so when we talk about digital twin, so multiple teams have involved. So let's have an example from Nailsoft side. So we have a different teams across at Nailsoft. Let's say the person is looking into the beam side. So we also have the RNA team, nail automation team. So these teams are specialized into the automation side, the IoT integration side. It may be a BMS, SCADA, and again we have a team who also look into the AIML side. So all those contributions from really helpful to have the particular delivering the digital twin solution.
Next question Shivam has asked is what level of detail LOD is generally preferred for beam execution in large scale data center projects?
The LOD is not dependent on what kind of project it is. LODs typically depend upon what purpose for which you are building a model, what level of design, what stage of design are you in. So level of detail keeps on improving from LOD 100 to 400 and 500 as built for a beam model. It has nothing to do with size of the project or type of project. It has to do with what level of design you are in. So as you develop design goes on going forward, like concept design, schematic design, detailed design, and shop drawings and fabrication drawings, the model gets enriched in terms of LODs.
Yeah, over to you, Pragya.
Yeah, we have few more questions, Sandeep and Prasanna. Can this be tried for existing data center and on a small portion?
Yes, it can be. So we have been talking to some of the ongoing data center operators in terms of understanding what systems they have in place in terms of the BMS or the infrastructure management systems that are in the data center, and we can certainly develop a digital twin for that, and also use the EnviroOptimus system for doing the monitoring.
What are the timelines for these small areas?
Let me answer about timelines. So let's say the BIM model is perfectly fine, and the question about the integrations. So definitely that can be achievable within 1.5 month period of time for creating a digital twin for a short portion of size.
Okay. How does real-time CFD integration improves thermal management? Prasanna, if you.
Yes, because by doing on real-time integration, you are able to track the temperatures, the velocities in the cold ice and hot ice. Typically, that information is very important when it comes to thermal management of any space, and so more for the data center, because the scenarios can change very rapidly based on the performance of the racks.
Over to you, Pragya.
Yeah, okay. Thank you, Sandeep, Prasanna, and Aniket for the wonderful session. And thank you everyone for joining us today. We hope the session gave useful insights into how digital twins can support smarter and more efficient data center operations. For more details or for more information, please contact us uh, for the demo and other details. You can visit our website envirooptimus.com and you can connect with us. Thank you everyone.